Okay, so the James Webb Space Telescope, or JWST, spotted something super weird, light beams that look like they're coming from a city way out in space. This has got people talking about aliens again. The telescope was pointed at Proxima Centauri b, which is the closest exoplanet we know about, and it saw these crazy bright flashes. Could it be aliens? Keep your eyes peeled for more info. People have been dreaming about life beyond Earth forever, and any hint of it gets everyone excited. But this time, it's a big deal because the James Webb Space Telescope found some pretty cool signs of life out there. While checking out the universe, it saw something strange on a planet super far away, lights that look like they're from cities. This makes us think there might be a non-Earth city on that planet. Scientists are really hyped about this because it could mean we've finally found intelligent life that lives in ways we're only beginning to think about. NASA folks are like, whoa, because they're seeing this city like light from 4 light years away. And they're wondering how long it's been shining before we had the tech to see it. David Kipping, a skywatcher at Columbia University, said that the planet where the lights are is super complex. Normal planets just soak up sunlight and then give off heat as infrared waves, but this one's different because of how it hangs out with its star, Proxima Centauri. This shows how important the James Webb Space Telescope is. Because it can see infrared light, it was able to spot the weird things this planet is doing, which helps us figure out what its atmosphere is like. Researchers want to keep using the telescope to check out the planet's air and see if life could live there. The James Webb Space Telescope is really good at seeing infrared signals, so it can even see what's happening on Proxima Centauri b when it's nighttime there. Other telescopes can't see dim lights in space, but the Webb telescope is awesome at spotting even the faintest glow. That makes it perfect for finding out if those city lights on the dark side of Proxima b are real. It can sense artificial light in space as long as it's in a very specific range, which is much smaller than the light from stars. Proxima Centauri b and its star are really close, so the planet's environment is heavily affected. It gets a lot of radiation from Proxima Centauri. It has days and nights like Earth, with hot temperatures during the day and freezing temperatures at night. The planet's structure determines how different the temperatures are. If it has air, the difference between day and night temperatures would be extreme, burning hot on one side and icy cold on the other. Scientists are really interested in these temperature changes because they tell us about the planet's air. The James Webb Space Telescope can look at the planet's heat and tell us what its atmosphere is like because it can see infrared light. The telescope goes around Earth at the same rate that Proxima Centauri b goes around its star. This allows scientists to get good recordings of its light phases every 11.2 Earth days. If Proxima Centauri b has air, the next thing to do is figure out what's in it to see if life could exist there. If we found things like oxygen, water vapor, and methane, that would suggest life could be there. To do this, we have to study the starlight as it goes through the planet's air, which is tricky. While the James Webb Space Telescope is great at figuring out planetary atmospheres, it wasn't made for that. It's really good at finding water vapor, carbon dioxide, and methane. It's not as good at finding free oxygen, which is a major sign of life. But it can still look for other important things like ozone, which tells us if the atmosphere is stable. As scientists look at the information coming from the James Webb Space Telescope, the mission to find planets far away keeps moving forward. We're getting closer to finding out if we're alone in space. It's important to know that JWST can only look at a few nearby exoplanets. To check out the atmospheres of planets that are farther away, astronomers will use Earth-based telescopes like the Extremely Large Telescope, or ELT, which should be up and running in 2027. The ELT will give us a better look at distant planetary atmospheres and tell us more about whether they could support life. Scientists are super excited for the next generation of space tools like the ELT. In the meantime, the James Webb Space Telescope is still awesome for checking out far-off exoworlds. Even though it has some limits, it keeps giving us important finds that could change the way we think about the universe. Experts have big hopes for future telescopes. They want to build systems that block out the light from stars so we can see the planets around them better. Like when you block the sun with your hand to see something small next to it, these new telescopes will focus on the faint light that bounces off exoplanets. This will let us get a better look at their air and see if they're livable. It's not easy, though. Stars are so bright that they often make it impossible to see the light bouncing off the planets around them. To fix this, researchers are coming up with some cool methods. One good method is to use coronagraphs, which are like sun visors inside telescopes that block out the star's glare but let the planet's light through. Coronagraphs make the starlight weaker, which helps us see the planet's light. Another cool method is the star shade, which is a giant spacecraft that looks like a flower. It works with a telescope that's super far away, tens of thousands of miles. The star shade blocks the starlight before it gets to the telescope, so the only light that gets recorded is from the planet. This seems like a good way to see planets in the habitable zone of their stars, the area where liquid water and life could be. However, these methods have to be super accurate. For example, the star shade and the telescope have to line up within a few millimeters, even though they're so far apart. Plus, these systems need to be small, use very little power, and be able to survive in space. Even though it's tough, the potential payoff is huge. If we can see and study alien skies, we might find biosignatures, chemical clues that suggest life. Things like oxygen, methane, and water vapor in certain amounts could point to life, giving us the best proof that we're not alone. Researchers are also working on ways to take better pictures of distant planets. Future tools could use smart adaptive optics to fix blur caused by Earth's air or telescope movement. Centauri b, a nearby exoplanet, could really kick off a groundbreaking time in space study. This work isn't just about getting facts, it's also about some big questions. What would it mean if we knew we weren't alone? How would being in contact with another advanced civilization change us? The excitement about Proxima Centauri b makes us remember how much we wonder and look for meaning beyond Earth. Future space telescopes, whether they're orbiting above or on the ground, will keep pushing the limits of what we can see. They'll have better ways of blocking starlight, clearer images, and better ways of spotting stuff, which will let us check out far-off exoplanets really well. Besides finding signs of life, they might someday find technosignatures, signals or structures that point to advanced tech. With every new mission, the James Webb Space Telescope is good at picking up infrared signals, so it can see what's happening on Proxima Centauri b, even when it's dark. Normal telescopes can't always see faint signals in space, but this one can catch even the weakest light. That makes it perfect for confirming if those city lights on the dark side of Proxima b are real. It can spot fake light in space, as long as it's in a specific frequency range that's way smaller than what stars put out. Proxima Centauri b and its star are pretty close, which affects the planet a lot. Like other planets, it gets a ton of radiation from Proxima Centauri. As it goes around the star, it gets cycles of light and dark, just like Earth. It's super hot during the day and freezing at night. The temperature difference is huge and mostly depends on what the planet is made of. If it has an atmosphere, the difference between day and night would be extreme. One side would be burning, and the other would be icy. Astronomers are really into these temperature changes because they tell us a lot about the planet's atmosphere. The James Webb Space Telescope can see in infrared, so it can check out the planet's heat and learn about its atmosphere. The telescope also goes around Earth in sync with Proxima Centauri b's orbit. That means experts can get detailed info about its light phases every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step is to figure out what's in it to see if life could live there. Oxygen, water vapor, and methane would be good signs. To do this, they'll need to study starlight as it passes through the planet's air. It's a tricky process. The James Webb Space Telescope is great at figuring out what's in a planet's atmosphere, but it was mainly built for other stuff. It's really good at finding water vapor, carbon dioxide, and methane. It's not as good at finding regular oxygen, which is a key sign of life. But it can still look for other things like ozone, which means a stable atmosphere. As experts look at the data from the James Webb Space Telescope, the hunt for planets keeps going, pushing us closer to knowing if we're alone. It's worth noting that the JWST can only check out a few nearby planets. To really explore alien atmospheres, astronomers will need to use telescopes like the Extremely Large Telescope, ELT, which should be up and running by 2027. The ELT is supposed to give us better info about planet atmospheres and tell us if they can support life. Scientists are hyped for the next-gen space tools like the ELT. In the meantime, the James Webb Space Telescope is still super valuable for checking out faraway worlds. Even though it has limits, it keeps giving us important info that could totally change how we see the universe. Experts have big dreams for future telescopes. They want to build stuff that can block out the brightness of stars so we can get a better look at the planets orbiting them. It's like shielding your eyes from the sun to see something small next to it. These new telescopes will focus on the faint light from planets so we can check out their skies and see if they could be livable. But it's not easy. Stars are so bright that they often drown out the light from their planets, making it hard to see them. To fix this, researchers are coming up with cool new stuff. One idea is to use coronagraphs. These are tools inside telescopes that block out the star's glare while letting the planet's faint light through. They redirect light waves to reduce the star's interference, which makes it easier to see the planet. Another idea is the Star Shade, a giant, flower-shaped spacecraft that works with a telescope that's super far away. The Star Shade blocks starlight before it even gets to the telescope, so the telescope only sees the planet's light. This is good for seeing planets in the habitable zone of their stars where there might be water and life. These techniques have to be super precise. For example, the Star Shade has to line up with the telescope within a few millimeters, even though they're thousands of kilometers apart. These systems also have to be small, use little energy, and be tough enough to survive in space. But it's worth it. If we can see and study alien skies, we might find biosignatures. These are chemical traces that suggest living processes, like certain combinations of oxygen, methane, and water vapor. That would be some of the best proof that there's life out there. Researchers are also trying to get clearer pictures of faraway planets. They might use smart adaptive optics to fix blurry images caused by Earth's atmosphere or the telescope's movement. Combine that with light-blocking tools like coronagraphs and star shades, and we could not only find planets but also map their surfaces and see their weather. That would be a huge step in understanding alien worlds and seeing if they could support life. As we keep exploring the stars and getting better at seeing distant objects, the James Webb Space Telescope and the telescopes that come after it will be vital. Its ability to sense infrared patterns helps it find faint heat signatures, figure out what's in atmospheres, and spot potential biosignatures. With constant scientific progress and more data from space, we're getting closer to figuring out if we're alone in the universe. Spotting city-like lights on Proxima Centauri B would be a huge step in space exploration. This isn't just about collecting facts. It's about big, philosophical questions. What if we found out we're not alone? How would meeting another civilization change us? The buzz around Proxima Centauri B reminds us that we're curious and want to find meaning beyond Earth. Future space telescopes, both in orbit and on Earth, will keep pushing the limits of what we can see. With better starlight filtration, sharper images, and more spectrum analysis, we'll be able to explore planets with amazing accuracy. We might even find technosignatures, which are signals or structures that suggest advanced tech. With every new mission and every tiny bit of data sent across space, we're getting closer to answering one of the biggest questions: are we really alone?